So welcome everybody. We're going to talk about SQL Server 2017 on container platforms like Kubernetes, Docker Swarm, and OpenShift today. So I just want to ask a question at the outset here. I want everybody to raise their hand. Just self-evaluate yourself on your level of container knowledge, in particular running databases in containers on container platforms. Let's start with 1. You have no idea what a container is. Anybody? Okay. 2. We're going to go up to 5. 2. Okay. 3. Okay, that's good. Okay, 4. Okay, and 5 is you should be up here giving the presentation, not me. That's my trick question. All right, did you bring your slides and your demos and everything? Okay, awesome. All right, very good. So it seems like there's maybe between a 2 and a 3 average, which is about what I sort of expected. So I'm Travis Wright. I'm a principal PM on the SQL Server engineering team. I've been focused on bringing SQL Server to Linux for the last couple of years, but I also do machine learning services in SQL Server, running SQL Server in our hosting providers like AWS and GCP, Azure IaaS VMs for SQL Server, and lots of cool stuff, right? So, and then I'm joined by Nick today. Nick, you want to introduce yourself?
Nicholas Gerasimatos.
Use your long name. You got to use the long name.
Nicholas Vasilios Demetrius Gerasimatos. Oh. I work for Red Hat in the technology evangelist group, specifically focusing on infrastructure and platform as a service, containers, and other emerging technologies.
Okay, awesome. Thanks, Nick, for joining me. So let's just kind of go over the agenda real quick. So I'll give you guys just kind of a quick intro for those that may be kind of new to running Docker containers and SQL Server in particular in Docker containers. Then we'll go over some of the benefits of doing that, and we'll talk about kind of how to deploy SQL Server into a container platform. And by no means is this going to be a comprehensive thing for all 3 of these container platforms and down to like the nitty-gritty details of YAML files and so on. If you want to learn that kind of stuff, then Nick has a 5-hour presentation he'd love to give you. And how many slides? 200?
228.
Yeah, so you can sign up for his course. That's fun. But we'll at least give you guys some things to take away and think about. And then at the end, I'll share some kind of things that I've learned along the way and some next steps on how you can start to learn more about running SQL Server in container platforms. So to begin with, I kind of just want to set some context here that, you know, the new reality is that data is just becoming more and more key to everything we do, whether it's in business or anything else. And the agility to respond to how you handle that data and the agility you have in terms of like rolling out new versions of applications and realizing the value of that data is really the only hope of survival. And if you just kind of look at some of the things that have happened recently, longevity is just not a given anymore. In terms of the companies and the average tenure that they have on the S&P 500, that's really fallen off over the last few decades to where an S&P 500 company is only expected to last 14 years on the S&P 500 by 2026. It's just falling off dramatically, and this is just caused by rapid disruption. And you kind of marry that together with the fact that mergers and acquisitions had their biggest year ever last year in 2016, and this pace of innovation that's happening is just only getting faster. So we have to figure out how we can evolve our data and our data platform and applications that run on top of it at a faster rate. If you just kind of think about some of the disruption and how fast it happens anymore, right? Let's take Uber as an example. It was founded in 2009. It has a $60 billion valuation. It's a private company, and it's in 574 cities, and this data is actually a few months old now. And Tesla was founded in 2003. They have a bigger market cap than Ford, right? And Airbnb, and Ford was founded, what, like almost 100 years before that? Airbnb was founded in 2008, and it has a valuation of $31 billion, which is almost as large as Marriott, which is the largest hotel chain in the world. And Airbnb doesn't even have any assets to speak of, right? This is how fast technology is disrupting the status quo. So if you kind of think about how software has been built and delivered over kind of the last few decades, it's really changed a lot, where we used to have like purpose-built systems like they would put on the space shuttle. And a release cycle, I looked it up, it actually took 8 years for them to develop the software that went out on the first space shuttles. That's a long release cycle. Can you imagine working on a project for 8 years? That's weird. It seems sort of unfathomable these days. And the size of the code was only 500,000 words that they shipped. It was a little baby, you know? But it actually flew a space shuttle up into space and brought it back. It's pretty amazing. And over the years, we've kind of evolved through packaged media on diskettes and CDs and so on. And kind of the next phase in this evolution of how we build and deploy software is containers. Containers are really taking over where VMs were for the last 15 years or so. Containers are now the new way that we want to deploy software because it gives us a lot of benefits that we'll go over. And it makes it easier for us to just deploy this software potentially multiple times a day. And oftentimes we're actually going to be pulling and running and deploying container applications like billions of times because we're continuously pushing it out all the time. So in order to realize the value of this containers motion, we have to kind of think about this in the context of DevOps. And we really need to think about DevOps as a pairing between developers and operations in a way where we can challenge the status quo, embrace this emerging technology, and deliver value to the business or whatever organization we're working for in a way that wasn't possible before. And containers is one of these fundamental shifts that's happening in our industry that will enable really a transformative change in how we build and deploy software and are able to be more agile. So I would ask you, are containers a fad or are they a fundamental transformation, right? And if you kind of think about the benefits of containers, they give you all the benefits of VMs in terms of isolation, portability, it's duplicatable and so on. But you also get these other benefits. It's much smaller on disk because you share the operating system binaries, right? The operating system binaries are shared up into the containers. You only have one copy of the operating system binaries. You have reduced CPU and memory consumption because you only have one copy of the operating system processes running on the host. You have reduced deployment size because you're only moving around the code files. So the container that you're pushing out is much smaller than it would be if you were pushing an entire virtual machine with the operating system inside of it. You have to patch much less often because you aren't patching the operating system inside of all the VMs, you just patch the host, right? You don't have to worry about patching Windows or Linux for every VM that you have. And it's more easy to compose these because of the layered architecture of container images. So you can put together layers that compose different things. Like I can have a database and I can have other application files that go into that image that go along with that database. And it's much easier to share them because I can just put container images up on Docker Hub or Store or an internal private registry that I have. And it's very easy for me to share around an image because it's smaller, because these registries exist that I can use to distribute my software around and make it easy for people to get to it. So it gives us all these benefits that virtual machines really don't, right? So this is really not a fad. This benefit that we can see here is something that is so valuable that it's just exploded on the scene in the last few years and people are really jumping on it. But there are some naysayers. There are people that would say, containers are ephemeral, meaning that the data that you put in them is not persistent. And containers aren't for anything critical. I should just be able to kill a container whenever I want, and it's not important. And ultimately, even pretty well-recognized people in the industry have said containers aren't for databases. That's an interesting statement. I would say that, in fact, these are all myths. These are things that have kind of persisted throughout the last couple of years because some of these things were, in fact, true a few years ago. But as containers and container platforms have evolved, a lot of these things are now really just myths. And in fact, if you just kind of take a look at the data, wow, that's a triple myth. All right. Docker loves databases. If you go up to Docker Hub and you look at the top 10 list of most pulled images, I think it's 4 or 5 of them now are databases. It's some of the most commonly deployed images in the Docker ecosystem. And you can see some of the other database engines and how often they've been pulled. And even in the first about 10 months or so since we've put out the MS SQL Server Linux image, we've had 2 million pulls of that already. It's by far the most common way that people have acquired the SQL Server on Linux package to go and run. So this is a very popular way to grab databases and run them. So regarding one of the myths about data being ephemeral inside of a container, that is true. If you put something inside of a container like a database, and you stop that database and stop that container and you remove that container, the database will be gone. That's bad, right? Don't do that. There are ways to persist the data if you're using containers. You can mount to local storage, you can mount to remote storage, and you can even use a Docker volume container, which is a container that sits side by side with your SQL Server container, and you put all your database files in that container. And then you can stop and remove the SQL Server container and bring it back and just remount it to the data container. So there are options about how you persist your data, But the key to this is that you have to read the documentation, right? This is like RTFM underscore bold exclamation point. You must read the documentation and understand how data persistence works in containers and container platforms. So I put the link to sort of the basic Docker documentation on Docker volumes. Definitely start there, read that. And as you start to evolve into running these things in container platforms, you'll need to read the persistence stuff for each of those container platforms so you understand how that works. Okay, so when you build and like test locally in your dev environment on your laptop or your desktop, you have a few options. Let's say you're running Windows. You have the most options. Look at you, you're lucky. You can either run Windows containers if you're running Windows 10 Anniversary Edition or newer, or you can run Docker for Windows on your machine, which creates a Linux VM on Hyper-V that has Docker Engine inside of it. And then you can just manage your Linux containers running in that VM through the Docker command line utility as though you were running on Linux almost, right? So you can run Linux containers or Windows containers on Windows. If you're on Mac OS, you can run Linux containers if you have Docker for Mac installed, which is basically the same thing as Docker for Windows, except they use the Hive hypervisor on Mac. And then if you're on Linux, if you have a Linux dev environment, you use Docker Engine natively. You just install Docker Engine, and you can pull and run containers natively on your machine there. And there are other container engines out there that you can use, but by far the most common one at this point is the Docker Engine. So I'm going to show you a demo of using Docker containers on a Mac in a minute. So let's look at a few different application patterns that we can see, right? So one is where you have kind of your traditional pattern where you have a centralized SQL server and you have some apps that are connected to it, right? So this could be a VM pattern, but we can also do this with containers where I have a central SQL Server container and I have some app containers and they're connecting to the SQL Server container. It's the exact same pattern that we've all seen for 20 years now probably, right? Another pattern that we can do is where we have a Docker Compose. And Docker Compose allows us to specify that this SQL Server container and this app container, or maybe even containers, go together. And I can start them up together, and they can connect up to each other, and I can deploy them together, right? Whereas with the first one, I would deploy my SQL Server container, and I would deploy my app containers separately and just point them at the SQL Server. And then the last one is where we have maybe either a monolithic app or a microservice app, where maybe I deploy my app container and my SQL Server in one container, right? So this might be useful in a scenario where you want to have a scalable microservice component where you maybe have like a static set of data that's sitting in SQL Server like a product catalog, and you want to present that through an API so that an application can call in and get your product catalog. And you want to be able to scale that up and down dynamically. And each container that comes up needs to have its own copy of the product catalog. So there's different ways that you can do this. There's not really any one right answer. But today I'll show you kind of how we can do this with a Docker Compose application. All right, nobody's left yet, so this must be mildly entertaining.
No pressure.
Yeah. Nobody leave. Okay, so let's go into the terminal. No, really, let's go into the terminal. There we go. Okay, so I'm going to Docker pull Microsoft MS SQL Server Linux. And what that's going to do is that's going to go out here to Docker Hub, where we have the Microsoft organization, and we have the MS SQL Server Linux repo. And here we have all of the images for MS SQL Server Linux, and you can see on the tags here that we release a new image for every version. So up until now, it's been like CTPs and RCs and so on, and on 10.2, next Monday, we will have the GA image available up on Docker Hub as well. So if I go into my terminal and say Docker pull Microsoft MS SQL Server Linux, it'll go out there and immediately download that image. And wow, that was super fast because I already had it cached, right? Okay, so now I'll run Docker images, and you can see that I already have this image pulled down here. And now I can run a container based on that. So I do Docker run. Now, when you run a SQL Server container, you need to pass at least these two environment variables to it. Okay, accept EULA, to accept the license agreement. We got to keep the lawyers happy, right? And the other one is SA password. So you set the initial password for the system administrator account, And I definitely recommend once you get your container up and running, if it's something that you care about people not getting into, that you change the password after you get it up and running, right? And then the other one that you can pass in if you want to is MSSQL_PID, product ID. And here I can specify something like which edition I want to run, like maybe developer, which is the default, right? And then I specify a port mapping of 1433 to 1433. This means that the 1433 port will be exposed outside the container so that applications can connect to it, and it will map to port 1433, which is the default port for SQL Server within the container. And I'll run it detached with -d, and then I specify the image to run. Okay, there you go. I have SQL Server running on my box now, right? I can do it in one line even. If I just do the Docker run, I don't even do the Docker pull first, it'll pull the image if I don't already have it. So this is a beautiful way with like a single line to your terminal. You can pull down and run a SQL Server container on your MacBook in a matter of like either a fraction of a second if you already have the image, or within maybe less than a minute if you need to pull the image down depending on your network speed. So now that I'm up, I can do Docker PS, and here's my container. I can do something like Docker exec -it into my container. Now I'm inside the container at a bash prompt, and I can do something like, I don't know, cd var, let's go cd opt ms SQL tools. And you can see that I'm inside of here, and now I can go bin, and here's SQL CMD. So now inside of there, we put the SQL CMD tool just for convenience. And I can use that to connect back to that SQL Server container that's running inside of it. Right? Now I can do something like select add version. Right? So it's just SQL Server. It's running inside the container. I can even connect up to it from outside the container. So I just fire up a new Visual Studio window here. And you can see that I'm connected to it down here. And I can do the same thing. There you go, right? It's just SQL Server. It just happens to be running inside of a container. And then when I'm done with it, I just can kill it. So I just specify the ID of the container I want to kill, and now it's gone, right? This is what's so beautiful about containers in a dev environment. It's just so easy to bring them up, tear them down. I don't really care about them. And I don't have to install any software. I don't have to keep it up to date. It's just very lightweight and easy to use. So now let's try using a Docker Compose application. So here I have a Docker Compose file. And Docker Compose files describe the different containers you want to have be connected together and brought up together as an application. And in this case, we have two containers. One is web, which points to the directory that this Docker Compose YAML file is in, and it builds all of this ASP.NET code for this application at the time that I want to deploy this Docker Compose application, and it exposes the port 80 on 8000, and it depends on the DB container, which is here. And in this case, I've published an image that has SQL Server in it. I started with MS SQL Server Linux image, but then I also put some stuff in it, like a database file that is now in the image, so that when a container is brought up based on that image, the database is already there, right? And I put this image out on an Azure container registry that I have out here on Azure. So you can see here's my DB dev small. So when I Docker Compose up this application, it'll pull that image down. And in fact, if I go to Docker images, you'll see that right here, right? So I've already pulled that image down, right? And now I have this container image, and when I fire it up, the database will already be there. The app will come up, it'll connect to the database, and it'll be beautiful. So let's, actually over here, Docker Compose up this application. So you can see that it's starting the SQL Server container, right? That's all this output here. And it started up the web application, which you can see here. And now it's doing a .NET EF migrate to use Entity Framework Migration to migrate the latest schema to the database. And now the application's up. I just open up my browser, go to port 8000, give it a little second for a JIT compile, and there we go. I've got Kentucky University up and running on my machine. Now the beauty of this is that I, as a developer, if I'm new to the team, All I have to do is go to the GitHub repository or whatever I'm using for source control, git clone that project down to my machine, and Docker compose up. And I have a working development environment in 2 commands. It's just absolutely beautiful. No more installing software or trying to use vagrant boxes or any of that kind of stuff. You just git clone and Docker compose up and you're working, right? And then the other good thing about this is now I can take this application and I can deploy it up into a container platform like Kubernetes or OpenShift or Docker Swarm, right? So this is just kind of a quick introduction to how you can use SQL Server and containers for a local dev environment. So let's go back to the PowerPoint now. And we'll switch gears a bit here and start talking about container platforms. So there's lots of container platforms out there. You have choices. Choice is good. Choice can be confusing sometimes, but choice is pretty good. So let's talk about Kubernetes first. Kubernetes is an open source project. It was started by Google. And it is, I would say, sort of the most mature so far out of all the different container platforms. And quite a number of the industry players have started to kind of rally around Kubernetes, including Amazon, Microsoft, VMware. It seems like every week or two there's some new big industry player that's come and has talked about how they're going to support Kubernetes, right? And then Kubernetes as an open source project is the foundation of some commercial software which is now available, such as OpenShift from Red Hat and SUSE's relatively new container as a service platform. Those are both Kubernetes based, but the idea with that is similar to kind of how Red Hat deals with Linux as an open source project, but then they have a commercial distribution of RHEL, which is enterprise ready, right? You can think of OpenShift or SUSE CAS as being enterprise ready, fully supported distributions of Kubernetes. It's kind of the way to think of it. Is that a good way to think of it?
Good way to think of it.
All right. So that's kind of one family of container platforms. And then Mesosphere is another company that originally started out building a container platform based on Mesos, which is an orchestrator. And they called theirs Mesosphere DCOS. But they just recently have also announced that DCOS will now support both Mesos and Kubernetes, right? So they're, again, kind of one of these industry players that's also getting involved in the Kubernetes space. And then there's Docker Swarm. So Docker Swarm is from Docker, the company, which is kind of the company that is one of the obviously main contributors to Docker, the open source project, and Docker Swarm is their commercial container platform. But it is not based on Kubernetes. It's its own distinct thing. So there's these different kind of container platforms out there that you can use. And then there's different ways you can deploy it. So you can deploy one of these container platforms in your own environment on some VMs in your data center, for example. You can deploy it into IaaS VMs in a hoster or a cloud like Azure. Or many of the public clouds like Azure, AWS, and GCP offer containers as a container platform as a service. So Azure has Azure Container Service. Google has Google Container Engine. I don't know what's wrong with those guys. Why did they come up with an acronym GKE for Google Container Engine? I don't know. And then AWS EC2 Container Services is another option, right? So anything to add on there?
Nope.
No? Okay. So you have options, right? And these things are just evolving at a very fast pace. There's new releases that come out of these container platforms all the time. So a couple of real-world examples for you. The SQL Server engineering team actually uses a Kubernetes cluster in Azure VMs for automated testing of SQL Server on Linux. So you can imagine that we had a pretty sophisticated test infrastructure for SQL Server. After building this for like 20 years on Windows, there were a lot of dependencies on Windows as far as our test infrastructure went. So what we did is we tried to kind of extract out our dependencies on the Windows OS for our test infrastructure. And one of the ways we did that was we started deploying SQL Server instances into containers on Kubernetes in Azure. And then all the tests execute primarily remotely on Windows machines, but they just connect to those containers. And they execute their tests. So we have about 700 containers that get spun up every day to do our automated test run. And we run over 1 million tests against those 700 containers. We have 150 of these VMs in Azure, and each of them has 128 gigs and 8 cores. And we sometimes stack up to like 20 containers per VM. So we get much higher density of testing this way as opposed to deploying virtual machines for our tests. Not only do we get much higher density, but it also lowers our costs and it makes the test execution times much faster. As we'll see here in a minute, it takes a second to deploy a new SQL Server container onto a Kubernetes cluster if the image is already there, as opposed to potentially several minutes to deploy a virtual machine in Azure. Much, much faster for us. So another example that we saw in Scott Guthrie's keynote and Rohan's session yesterday is a company called DVO1. They're a financial tech company in New York, and they originally started out on Postgres RDS and AWS, and they moved from there because they weren't getting the performance they wanted to SQL Server on Windows in VMs in Azure, and then they went to SQL Server on Linux VMs in Azure once that was available, and now they're running in production on containers on Linux VMs in Azure. And they have about 100 cores supporting 40 databases that range in size from 50 to 500 gigs, and they're getting 30 times better performance than what they saw with RDS, and they've reduced their operational cost by 90%. And they've been in production on these containers since CTP 2.0, which was back in like April or something. So awesome story. These guys are very progressive on these kinds of things, and they've been rock solid with running on containers so far. All right, so let's kind of think about some of the benefits of running on container platforms. The first is that you have faster time to deployment, which we'll see here in a minute. You can package your dependencies with SQL Server. So as I mentioned, I put my database inside of the container image, right? So if I have a database or I have some maybe script files that need to be executed, or I have some extensions to like R or Python libraries, for example, I want to put in there, I can put all those files inside of the container image and deploy them with SQL Server. This will enable CI/CD and process automation. A lot of the CI/CD platform tools like Travis CI or Jenkins and so on, these are all focused on container provisioning at this point. So if you want to take advantage of those platforms to automate your CI/CD process, it's much easier to do that with containers now. And the next is that one of the beauties of containers is that you can dev locally on your machine using a container, and then you can push that same container into test, and then you can push that same container into pre-production, and then finally you can push that same container into production. So you deploy into production what you dev and test. Exactly. Right? There's no variation in terms of configuration or what dependencies are on the box or not on the box, or which patch level the operating system is up to, and so on. And it's another advantage of it is cross-platform. So especially if you're building on Linux containers, whether your developers prefer to use Windows machines or Mac OS or Linux, it doesn't matter. You just have containers, and everybody can develop using whatever tools and whatever operating system they want. So in that sense, the operating system wars are kind of over, right? If we can sort of, at least within the developer community, people can just use what they want. And nobody really cares what operating system is running inside of the container. If it's Linux, whatever. If you're running on Windows machine or your dev tools are Windows and you're connecting to a container, the fact that it's running on a Linux container doesn't really matter. It's just running there in the background. It's like a process. This also enables microservice architecture. So if I can deploy a SQL Server-based application in a microservice architecture onto a container platform, it makes it much easier for me to scale up and scale down my microservice components within that architecture. And that's one of the beauties of the way that these container platforms work, is that they're designed for that application pattern, microservice pattern, where you can automatically or manually scale up in an elastic way the number of containers that you have that are servicing a particular workload. And then lastly is when we have this container platform and we're leveraging containers, we have much lower disk space requirements, we have much lower network traffic going on, and we can just overall utilize our hardware infrastructure much better. So let's cover a few basics. I'm going to give you 3 demos of how we can deploy applications into various container platforms using different methods, right? We'll go into OpenShift via the portal. We'll deploy a container into Stack, or into Docker Swarm using a stack, and then we'll also deploy into Kubernetes using Helm. Sorry, I got like some weird thing in my throat. You guys are just going to have to deal with it. Just going to have to sit there, just wait. All right.
Has anybody left yet?
No.
No. I did see one guy. But
All right. So let's do some more demos. Let's start with OpenShift. Okay, so I'm here in the OpenShift web console. I've got a project created called Travis Test 4. Everything in OpenShift is organized by project. And you can grant people permissions to projects that they can only mess around within that sandbox, and you can give them quotas and so on. And in that way, you can have a multi-tenant architecture, typically within a single company. You might have different development teams or something like that that are using the same OpenShift cluster, and you want to partition out their access to things and control the resource allocations there. So to deploy a container into OpenShift, I can go up here and just add to project, and I can browse the catalog for some standard container images that are available on Docker Hub, for example, or I can deploy a particular image. So in this case, I'm going to deploy an image that's up on my container registry that we saw a minute ago, right? So in order to do that, I type in the container registry name, contoso u.azure.cr.io, MS SQL rel. That's the name of my image and the registry that it's on. And now I can go out there and I can search for that, and it'll bring back the metadata about that particular container image. Now, one important thing. If you want to be able to access a private registry like this one, you have to grant OpenShift the credentials to do so. And you do this by creating what's called a secret. So to do that, there's this command called OC secrets. So the utility called OC, you run OC secrets, and then you pass in all this configuration here that will create the credentials and store them in a secure way, so that when I say I want to pull an image from this contoso u.azure.cr.io, it will go and get those credentials and use it to access the registry and pull the image. Okay. So let's pull back the metadata about it now. And I can call this some name that I want. And then I can use the contoso u pull secret that I just created there. And I have to pass in the environment variables, just like we saw on my laptop a moment ago. So I do the accept EULA, I do SA password, Yukon 900. Okay, and I'm done. So now I just hit create, and this will go out and it will create a new container on the OpenShift infrastructure here. So let's go back to the dashboard here, and you can see that my pod is spinning up. Now, all these container platforms have pretty much the same concepts. There's a few variations in terms of the concepts, but especially since a lot of them are based on Kubernetes, they at least have the same concepts, and then sometimes they call them by different names. But a pod here is a collection of containers, right? So I can have multiple containers within a pod, and they get deployed and managed as a unit. So if I want to scale them up or down, I just hit this up or down button, and it'll deploy that set of containers or bring them back down to some level. And so you can see that within a few seconds there, especially in this case because I already had the image cached, it deployed out a container onto the OpenShift infrastructure. It's a very easy way for me to go out and deploy that container onto my infrastructure. Now, if I can go in here to logs, and I can see the output from the log. So this is the exact same startup messaging that we saw when I fired up the container using Docker Compose Up on my laptop, right? So I can see the output coming from that. So I know, in this case, based on the output that came out, that this SQL Server container actually came up in a healthy state and is ready to go. So let's now take a look at how we could deploy a container into, let's do Docker Swarm next. So this one's kind of an interesting one. In this case, I'm remote desktop into a jump box. And this jump box is sitting on network where I have, wait for it, suspense. It prompted me for cred, so it must be trying to do something. Okay, let's set that over here for a second. And we will do a Helm chart instead. Okay, so Helm is a command line utility that you can use to deploy what are called charts. And charts are similar to Docker Compose files. So for example here, we had this Docker Compose file that describes some services, in this case a web, a DB, and so on. So now let's take a look at a different way to look at this. So let's see. So I have this example voting app that has all these different containers. So it has a voting app, it's got a Redis container, it's got a worker, it's got a DB container. So these are like the worker is a Java app, this is a Redis cache database container, voting app is a Node app. So it's got all these different things. And you'll notice that the syntax of how you lay out a Docker Compose file is very similar to how you do charts. So like I can go here now and look at, well, let's see. We'll look at this chart here. So we'll look at the deployment YAML file. The deployment YAML file has a lot of the same kind of stuff. You have containers that you define. It has a name. You specify which image it's going to pull. You pass in the environment variables and so on. And I can deploy this chart out to an environment. So in this case, I've created a chart for the Contoso U application. And I'll just helm init, which fires up a Helm tiller, is what it's called in the Kubernetes cluster. And then we can just test to make sure the version's looking good. Oh. Come on. It's like this weird timing thing. There we go. Okay, so now we can Helm install Contoso U. And with a single line, we can deploy a application into Kubernetes. Okay. Oh. Hang on. I left around something from my last try at this. Okay, let's try that again. Okay. So it just hit a conflict because I'd already created a secret in Kubernetes. That's what happened. Okay. One more time.
Time's the charm.
That's it. If this doesn't work, everybody's going to walk out and leave. They're going to be so annoyed. Okay.
All right, I'll catch you later.
Yeah. Come on. Demo gods are with us. Oh, yeah. There we go.
Love
Okay.
the name Melting Sloth.
Yeah, I love how this generates these awesome names. Okay, so now we can see that it's started deploying things out here. So I have a deployment, I have a pod, I have a replica set. Maybe none of this means anything to you, but at the end of the day, like it's basically the same thing as what we just saw in OpenShift. Within this pod, I have two containers. I have the DB container, which we have here, and we have the web container. And it also created a service for me, which exposes, well, once it's done running here, will expose the application as an endpoint out where I can connect to it, just like you saw with like Docker Compose when I brought it up and I was able to connect to it. So with, again, like just so simple, I just run Helm install and I can deploy an application with its web pieces and its database and so on in a very consistent way. And I can just deploy that to one Kubernetes cluster for tests, and then I can just point it at another Kubernetes cluster and deploy it into production. It's the exact same chart, right? So let's see how we're doing over here. Okay, it's prompting me for creds. Okay, good. I knew RDP wouldn't fail me. Come on. Oh.
I feel like we have to do that iconic Steve Jobs thing where he makes everybody shut off all their Wi-Fi devices.
Yeah. Okay. Hopefully I don't have to do 3 times on this one.
Okay, good. So now, oh shoot. Forget you can't Alt-Tab inside of a remote session. Okay. So here, I've got a Docker Compose file that we were just looking at for the voting application. This is like the standard Docker Compose application for the Docker created for demos. And I've got the kind of the same thing over here as a Docker stack. And so Docker Compose file, Docker stack. What's the difference? The only difference really is that for Docker Compose, I have a build step in here. So when I'm Docker composing locally, I want to build my containers if I've changed the code. But when I deploy it as a stack into Docker Swarm, I want to just pull down a pre-built image and just deploy it. So in this case, I've pre-built the images and published them up to my repo on Docker Hub, and it'll pull down those images and deploy them. So what I can do is I can just, I can't even use my keyboard shortcuts in here. Select this stack right here is what they call it. Copy it. Nope, don't Alt-Tab. Wow, RDP is slow.
It's because you're using Chrome and not Edge.
Yeah, my mistake. Duh. Okay, so let's look here at, this is actually a Swarm cluster running in Azure Stack, which is kind of an interesting thing to be thinking about here. So we've got Azure Stack, we've got a bunch of VMs that are deployed on there, and that represents a Docker Swarm. And then we'll go into the universal control plane here. And we can go to the stacks place here, and we can create a new stack. And we can paste in the stack template that I had. Choose to deploy this as some services, and we'll call this voting app SQL, and we'll create this. So while this is going out there and creating, let's just kind of take a closer look at what's going on here. So inside of here, we've got all the images created ahead of time and pushed up to the repository in Docker Hub. And it's going to pull these down. So it's going to pull down the Microsoft MS SQL Server Linux latest image, and all the other application containers I pre-built, except for the Redis one. The Redis one is just the standard Redis image up on Docker Hub. So it's going to pull all these things down, fire them all up, and they're going to connect to each other because they're specified, they're connected over here on links. And we have these front tier and back tier networks. Don't do that. Okay, so this is now deployed. We'll hit done. And we can see that this is now deployed out a service. All of the services are up and running. If you look at the containers, you can see that those are all up and running now. And the services, just like on OpenShift or Kubernetes, will be exposed through IP addresses that we can get access to. So that's the worker one. So here's the voting app, right? I can hit the URL to open the link to the voting app. And I can also go to the result app, and I can hit the link to expose that. So you've got the cats and dogs demo app coming up, and for some reason the Node app takes longer to fire up. I don't know why. But once these are up, then we have the full cycle where I can vote on something. The vote goes into the Redis cache DB. The worker container is running in the background as a Java app, and it copies the vote from the Redis cache DB into the SQL Server container, and then the votes are presented through the results app here, which shows whether cats or dogs are winning. So why is this taking long? Anyway, the fact that the app works isn't really as interesting. It will work eventually, it just is slow for some reason. But the idea here that's important is how we can deploy SQL Server as part of an application, in this case using a stack on
Docker Swarm, in this case, kind of interestingly on Azure Stack, right? Like overloaded use of the word stack here, but that's kind of what's going on. All right, so let's go now back to the PowerPoint. You guys are probably tired of listening to me talk, so let's let Nick get up here and wow us with his knowledge of OpenShift in particular, and talk about some of the most important aspects of how you actually productionize your deployment of SQL Server and containers into a platform like OpenShift.
Thanks. So who here is familiar with how containers actually talk to one another, either on an individual host or across multiple hosts? Okay. So this is an example showing you specifically how the Open Virtual Switch packet flow, when you're using the host with like Kubernetes, for example, or OpenShift, how pod 1 talks to pod 2. So the virtual Ethernet that is actually attached to each one of those individual pods actually talks through a bridge, and it never actually leaves the hypervisor itself, okay? This is only if it's on the same individual host. If you're talking to containers on 2 different hosts, it's a little bit different. Both the vEthernet devices actually talk through a bridge. It actually exposes that route through a VXLAN, and then passes the traffic through the Ethernet interfaces that are specifically attached to those hosts, okay? And if you're going to talk to a completely external host, so maybe you're running your web layer or middleware, and you're talking to a hosted database on the back end, it will look a little bit like this. So vEthernet, same thing with the bridge, but then you actually have a tunnel that's being exposed, and then going to the Ethernet interface, and then you're connecting to external host. Let's just assume that the external host is a database, for example. Who is familiar with how routes work with container platforms? Okay, so a few people. So obviously, just like it kind of sounds, external traffic comes in through the router. The router is then exposed to a service, and the service actually handles the load balancing between pods, or actually the delegation or policies, things along those lines, right? And then pods that are supposed to actually only have ingress or egress can also be specified within the service itself, and then pass back up through the router to external traffic. So this would be things like DNS resolution, things along those lines. And as I was mentioning, with the service itself, you can do route split traffic. This is great if you're doing blue-green, A, B, rolling deployments, things along those lines. So you have your service A, this might be your production base application. Service B might be a new application that you're rolling out, and you're slowly matriculating things over as you actually test out your new code. So you don't want to actually commit yet until you actually see, oh, users are actually getting a benefit from it. One company that's really famous for doing this, and I don't think a lot of people realize it, is Facebook, for example. So out of everybody that's sitting here, not all of you are running the same version, even though it might say the same application version on your phone. If you're running the Facebook app, you'll actually be routed through a different series of layers. They're notorious for actually testing new services in this manner. So one thing we were talking about earlier is, persistent storage, right? Databases, they don't work in containers. They should only be used for stateless applications. Anything that actually has data persistence or has I/O, things along those lines, it's not going to work. Well, fact of the matter is containers need persistent storage. I have to find the source where I pulled this from. I think it was IDC. But 77% of data applications, people said, need persistent storage. All the way down to 46%. That's still greater than 40% of all applications. People are saying, we need persistent storage of some type, right? It could be object-oriented storage. It could be blob storage. It could be file system storage. It could be sharded storage. It doesn't really matter. They need persistent storage. And persistent volumes are tied to usually network storage, especially if you're talking about cloud computing. And typically, they're provisioned by an administrator, either statically or dynamically. And if they're provisioned by an administrator, they're usually provisioned up front, and then developers consume those on the back end when they're actually deploying their containers. They say, I need to do a persistent volume claim. And admins have the ability to describe the storage so that users know what they're specifically requesting. So I'm sure we're all familiar with gold, silver, bronze, or high performance tier 1, tier 2, tier 3 type of storage, right? And this could be anything from NFS and Gluster to Azure Disk, Azure Blob, Azure File, you name it. So how exactly does that work, in a sense, right? So the administrator registers persistent volumes, makes them available. The developer goes in, creates a claim. The pod then therefore goes based on those parameters that they're specified and claims whatever is being provisioned in there. Now, this works, but this doesn't really work well when you're talking about DevOps and when you're talking about the need to actually move incredibly fast when you're doing rolling deployments and things along those lines, right? We need dynamic volume provisioning. We need the ability to identify slow, fast, fastest storage, all flash or all cache or cache and flash or just archival storage. And this could be through, for example, NetApp, it could be on AWS, it could be in Azure, it could be blob storage. It doesn't really matter what it is at the end of the day. And the user should be able to actually specify those parameters of the storage that they want and have it actually dynamically allocated on the fly. Those volumes don't have to be pre-existing. So previously, we had to go and create these volumes, and they would sit there taking up space, taking up money. Now we're moving more towards a design where developers can actually say, I need this storage, it needs to be gold, and it needs to be in this geolocation, in this geography, and I'm deploying this pod to this region, and all of that can happen on the back end. Part of this is actually happening because of solutions like Hiketi. I'm not sure if anybody here is really familiar with it, but it's an open source project. And Hiketi actually ties into Kubernetes, it ties into OpenShift, it ties into almost anything. Let's see here. So what does container native storage look like then, right? That's kind of what Hiketi is. You actually have your Glusher storage, multiple bricks spread across multiple different nodes. These nodes can be also running containers. They're not just persistent storage nodes. So you actually have hyper-converged. And then you might have other nodes that are just running pods only, as you can see on the side over there. Those nodes can still be using storage, right? They actually could be mounting network storage from these other hyper-converged nodes. Now, you might have different tiering of storage. For example, one of these pools over here might specifically be regulated towards gold storage for high performance. Some of it might be coal-based storage. But the idea is that container native storage is something that we have now. We have it today. You could use it for your databases. You could use it for your persistent-based applications. You could use it for high-performance I/O. You could grow disks. You could actually take snapshots and backups and replicas, things along those lines. So secrets. We're not going to talk about secrets because it's a secret. I'm just kidding. So one of the greatest things that, at least I find in container platforms, is the fact of secret management, right? We all know passwords. We hate passwords. Passwords are just a headache. And SSH keys, yeah, they simplify things, but you know what? You still have to have your public and your private keys, and everything has to match. And then we have the idea of certificates. And certificates are great too, but once again, they have to match. And if you throw all these things together, yes, you get a very secure environment, but it's also incredibly complicated. What if there was a way to actually make this a little bit easier, right? So with secrets, you have the ability to make them available as environment variables to containers, to volume mount specifically, or interacting with external systems. They could do encryption at rest, encryption in transit, and they actually never persist or rest on the nodes. So here's an example of a secret being passed through. So you can see there's specifically a webhook for GOGS. So in this example, GOGS is actually talking to Jenkins. And Jenkins has the ability to actually pull from GOGS. If you're not familiar with GOGS, it's essentially Git. And we actually have the parameter specified in here under the type GOGS config, and then you see the URL. Through there, it's actually pulling the secret that we're specifically setting without actually us having to tell it what the secret is. It's going and it's pulling that. And if you'll notice, there's a $sign and then webhook secret specified there, so you could actually specify that as a variable, right? So at the top of the file itself, you could actually specify the variable and grab all of these secrets, so the secrets could all be persisted through a common framework or common naming convention.
All right, so awesome. So one of the useful cases for secrets is maybe you noticed in some of my deployment YAML files that we were looking at for like the stack or the Helm chart, for example. you don't want to put your passwords in those chart files because they're going to be checked into source control and so on. So one good way to handle all of that is that you use secrets. So you store the secret in like OpenShift, for example, and then you just parameterize it in your deployment YAML file. And then at deployment time, the OpenShift cluster will go and get that secret securely and use it at the time that it's being deployed. Okay, so now one of the last kind of remaining areas that we have to sort out is high availability within a container platform. So SQL Server on Linux relies on Pacemaker as the cluster manager for always-on availability groups as well as failover clusters with shared disks, right? So we could deploy multiple containers onto OpenShift or Kubernetes or something and put Pacemaker inside of those containers and configure Pacemaker to talk to each other, and it would just be like I was deploying it on VMs. But that's not really kind of the way that people do things in container platforms. The idea with containers is you have a single process running inside of there, not SQL Server and Pacemaker and a bunch of other stuff that runs in support of Pacemaker. And further, it's also kind of hard to get inside of a container and run configurations, scripts, and so on. And so that's just really not an ideal way of doing things. And plus, especially in container platforms, containers can kind of get moved around from node to node, redeployed, and so on. And having that come back up and rejoin the cluster reliably is maybe a little sketchy. So that's not the best solution. Another solution you could do is just have pod or container restartability, right? So we didn't really demo this today, but if you go in and you just kill a pod, or you kill a node that a pod is running on, the containers will be immediately like redeployed by the cluster platform, right? And depending upon what your recovery time objective is, that may be fast enough. A SQL Server container can be redeployed and come back up in about 5 seconds. And you might be thinking, that's actually pretty good. I could live with that, right, for some applications. The one caveat to that, though, is that it can take a variable amount of time for the database recovery to happen. So depending upon what activity has been going on inside of that database, SQL Server coming up is really just the first step, but then it has to recover the database, and that may take a second. It might take minutes or even hours, depending upon what's going on in that database. So it's an okay solution depending upon what your database is doing, but it's also, again, not ideal. We have support now in SQL Server 2017 on both Windows and Linux to create an always-on availability group, which is a replicated HA solution where I have a primary node, the data is replicated to multiple secondaries, and then I can choose to fail over to one of those if I want. So you could deploy multiple containers, set up those containers in an always-on availability group, replicate the data all across, and even if you lost your primary node, you could fail over and nominate one of the secondaries as the new primary. But that sort of requires you to be sort of sitting there monitoring it and manually doing the failover, or you'd have to script some automation that would go in and do the monitoring of things and orchestrate the failover if there's like an instance that's detected to be offline. Again, not really ideal because it's not like a built-in solution. It's not automatic failover. So there aren't really great HA options yet for SQL Server running in container platforms. So what I would recommend is that you use SQL Server on container platforms in scenarios where you don't have to have that database up 100% of the time, right? If you have a mission-critical application that you need to have automatic failover with super minimal recovery time, you should run it in VMs or on physical hardware with Pacemaker. But if it's a database that if it goes offline for some reason, it's not a big deal if it takes a little while for it to come back up. It could be seconds, could be minutes, could be somebody figures out it went offline over the weekend and you come back in and start it back up on Monday. If that's the kind of application that you have, then go ahead and deploy that on a container platform. And there's lots of examples of that. Even DV01 that we talked about before, like I mentioned, they have these, what was it, 100 databases or something running on top of these container platforms. And those containers, because they're resilient, they're good enough for them for what their purpose is, right? Now, going forward, we want to continue to work with the container platform engineering teams, whether it's OpenShift or the Kubernetes ecosystem, on creating some services within the container platform that can manage the HA for us better so that we can have that be kind of a service that's provided by the container platforms, and then SQL Server can just plug into that. Okay, one other note on management and monitoring. So monitoring is basically the same. You just connect to the SQL Server at the endpoint that you connect to, and you run some T-SQL queries against it, and you can get back the DMVs, and you can get back all the system information about how that SQL Server is performing. That's not any different than how you manage SQL Server wherever it's running. In terms of jobs, though, one quick note here is that you can either install the SQL Server agent inside of your container if you want and have the SQL Server agent inside of your container doing those jobs. That's an option. That's OK. I kind of put meh. That's all right. But you could also use jobs in the container platform. And this is like the super cool way of doing it, where you actually have a job that is a container itself. And the job will be, you can schedule it to come up on a particular interval. And the container can be spun up. And inside of that container, you can execute a bash script. And that bash script could use something like SQL CMD to connect to a SQL Server container or multiple and do things like backups or archive some data off, run some scripts to do maintenance jobs or whatever. But you're actually using the container platform to spin up these jobs and do them as opposed to running the SQL Server agent inside of the container. So it's kind of a cool way of doing it. Either way works, but some options for you. Can you use SCOM? Yeah. So there's a new Operations Manager management pack for for Operations Manager that will monitor SQL Server on Linux, and it does it remotely. And so what you do is you just go into the Operations Manager console and you specify the SQL Server IP addresses and names that you want to monitor, and then we'll do all that monitoring remotely. And they're just containers. You just expose the endpoints, and then I'm sorry? Except with SCOM on VMs, you have an agent running there locally. In this case, it's agentless remote monitoring. But also for Linux, if you're running SQL Server on Linux on VMs, you still monitor that remotely. Right? So whether it's running in a container or running in a VM or running physical, if it's SQL Server on Linux, it's agentless remote monitoring. OK, so a few lessons learned. We had some fun over the last couple of days getting ready for the session, trying to get the SQL Server container image that's up on Docker Hub to run on OpenShift. I'm not 100% sure, but I think one of the reasons we ran into a problem here is that that's an Ubuntu-based VM image up there. Not VM image, an Ubuntu-based image up there on Docker Hub. And just in general, like if you want to have a nice supported stack, you should run RHEL-based containers on OpenShift, right? Red Hat to Red Hat, and that's just a good way to go. The SQL Server container right now requires to be run as root, right? So, and a lot of the databases do. I'm pretty sure Postgres and MySQL both require running as root. By default, OpenShift doesn't allow containers to run as root. So you have to grant it permission to do that. And the command to do that is here. Nobody can read. Where is my mouse? There it is. OK. OK, so here's the command you have to run. You run ocedit sec restricted as a cluster admin. This will open up a VI editor, and you can go in and you can change the run as user. Oh, yeah. God, dang it. So you run ocedit sec restricted as a cluster admin, and then that'll open up a VI editor, and you can change the run as user .type attribute to run as any. And this will allow containers to run as root within, I think, the scope of that project. Yep. Right? OK, so that way you don't have to enable that for the entire cluster, but just for that particular project, you can allow containers to run as root. OK, so what else have we learned? So we've also learned that SQL Server requires 3.25 gigs of RAM for now. In an upcoming CU, I can't remember whether it's CU 1 or 2, we'll be lowering that to 2 gigabytes. So that'll enable you to run it in kind of a more compact scenario as well. -V volume mounting for persistence doesn't work on macOS right now. So in that scenario, you should use Docker volume containers if you want to persist your data. But don't delete your volume container if you're using it to store your data. Be very careful if you care about it. Oftentimes, you're just developing on a Mac. You don't really care about the data. NFS for volume mounting doesn't work in any container platform or if you're using Linux containers on Docker for Windows in RC1 and 2, and that is fixed in GA that will be available on Monday. SQL Server on Linux containers are the only type that are supported in production right now. SQL Server on Windows containers are available for dev and test. We have images available up on Docker Hub. You can go and grab those. But please only use those for dev test scenarios. We have not done sufficient testing on those and we know that there are issues with it. So it works for the most part, but please don't use it in production just yet. We'll continue working on that to get it to a state where it's production ready, both in terms of usability as well as quality. And then for now, Kubernetes and OpenShift are the only cluster platforms that we officially support for deploying SQL Server on Linux containers into production on. That may change over time based on customer demand and our ability to test other container platforms. And just in general, my experience with trying to work with these container platforms is things are changing very fast, right? Like I do a session like this at a conference, and 3 months later I got to do it at another conference, and I can't just like reuse the same demos because things have changed, right? So it's very challenging to keep up with the pace of all of this, but it's really exciting at the same time. It's fun to learn all this new stuff and see these things evolve very quickly. And then just two things. One is make sure that you read and understand the best practice documentation that we have on docs.microsoft.com for running SQL Server in containers. And also make sure that you read about data persistence so you don't lose your data. And lastly, give it a try. You can go find the SQL Server image up on Docker Hub. You can easily pull and run it on any machine and just connect to it and start poking around with it. And then you can go get the OpenShift test drive. There's a URL here where you can go and get an OpenShift instance deployed quickly and start to play around with OpenShift. And really the best way to learn all this container platform stuff is just to sit down and spend some time learning it. And if you want to, Nick will give you a 5-hour presentation on it. All right, and then I put the GitHub URLs to all of the source code for the projects that we demoed today up here. And Eric, right here, raise your hand, Eric. Eric will be giving a session tomorrow, right, at 12:30 on SQL Server and CI/CD and just kind of how you can generally use some of the stuff that we talked about today to build automated CI/CD pipelines that take you from production all the way back through dev test and back to production again. So a very interesting session. It's actually been the #1 rated session for the last 2 conferences we've done. So I'd highly recommend going and seeing that presentation tomorrow. And with that, we have about 9 minutes left. If you want to come to the mic, we will take a few questions. Thank you guys for coming out, and please fill out your evaluations. Let us know what you think.